All right, good evening, students. I welcome you for another session on the properties of alcohols and phenols. We have discussed last time, students, the preparation of alcohols and phenols. Was it discussed or not? In the last lecture, we have discussed the what we have discussed, student, in the last lecture. The what we discussed, students, in the last lecture, we have discussed the preparation of the alcohols and phenols. So now is the time to discuss the properties of alcohols and phenols. Whenever we discuss, students, the properties, the first we discuss the physical properties that we are aware of. First we will be discussing the physical properties, student. And in the physical property, student, what we discuss most of the time? What we discuss most of the times are boiling points and their solubilities in water. Boiling point. So if we want to discuss, student, their boiling points. One boiling point, you know that on what factors the boiling point depends. On what factor the boiling point depends, students? It depends on the attractive forces between the molecules. And in the case of alcohols, what type of groups you have, what type of parts you have in alcohol. Consider this is my alcohol, student. And if I say phenol, student, what is your phenol? This is your phenol. Okay.
Yes, sir.
Now here oxygen is negative, hydrogen is positive, oxygen is negative, hydrogen is positive, students. But this group, what is this group? This group is not having any charge. What type of group is this? Hydrophobic.
Mm.
This group we call as hydrophobic group, student. Hydrophobic group which will not dissolve in water.
Yes, sir.
Here you have R group which is hydrophobic. So there are two groups, one which will dissolve in water and other which will not dissolve in water. But we can say that for lower alcohols, student, lower alcohols, what will happen if R group is small? If R group is small, students, then we know there is going to be intermolecular hydrogen bonding. Hydrogen bonding, students, in alcohols.
Mm.
So what will then happen? It will increase the boiling point or decrease, students. Hydrogen bonding does what? Increases the boiling point. Boiling
Yes, sir.
will increase, student, will increase. If you have alcohol or phenols, it will increase the boiling points wherever this will be possible. That means what is happening, student? R O H, if I write like this, student, and if I write HOR, what is going to happen, student, here? What is going to happen? HOR, large number of molecules are present, student, negative,
Mm.
positive, positive, negative, negative, positive, student. So what is going to happen then here? What type of bonding? This is your hydrogen bonding. This is the intermolecular hydrogen bonding, student, which will take place.
Mm.
So we will have intermolecular hydrogen bonding and the boiling point of the alcohols will be increasing. There will be hydrogen bonding, hydrogen bonding. So there will be increase in boiling points. Similarly, if I have phenol, student, in phenol, what is happening?
Mm.
You have phenol, you have HO, phenol molecules. What they do, students? Here, this is my negative, this is my positive, this is my positive, my negative, like this. There will be so many molecules. There will be so many molecules. What will happen? Here, this will be a hydrogen bonding, student.
Yes, sir.
So what will be the result of this? In general, we can say that what we find that alcohols and phenols, student, alcohols and phenols, what will their boiling point will be? They will have higher boiling points, higher boiling points. If we compare them with alkanes, or if we compare them with ethers, or we compare them with haloalkanes
Hmm.
or haloarenes, haloarenes. So this is important. A question has been asked on this, student. Question has been asked. So, for example, when we discuss what is a question, we should be able to do the questions also which have been asked in the paper, student. Papers. The question was, you have CH3, CH2OH,
Hmm.
then you have CH3O, CH3, then you have CH3, CH2, CH3. So
Yes, sir.
arrange them in increasing order, increasing order of boiling point. You have 1 minute to answer the question, students. The time is running out, students. Which has the highest boiling point out of the three? Answer is
Hmm.
clear. Alcohols will have the highest boiling point.
Yes, sir.
Ether.
CH3,
Yes.
CH2.
So you have the order will be, how do you arrange them in order, student? Such question has been already given in the board.
Hmm.
The reason you know that this is a hydrogen bonding, here is a only polar van der Waals forces, weak van der Waals forces, weak van der Waals forces, student. So we should be
Hmm.
aware of the, when we write the answer, what answer we are writing, on what basis we are giving our answer, student. So alcohols of course show hydrogen bonding intermolecular, therefore they have the highest boiling point of the three.
Hmm.
One more trend could be there in within the alcohol, when the number of carbons will increase, then what will happen? Uh, we can say that if R chain increases, student, then what will happen to the boiling points? Then there's what will happen if the number of carbons will increase naturally, what will happen? Then the solubility will decrease because the hydrophobic group is there. R is hydrophobic group. The boiling point will be changed in the case of the alcohol. The hydrogen bonding is there, but R group is hydrophobic group. R group is hydrophobic group, students.
Hmm.
So it will interfere with the, it will interfere in the case of the solubility. And I'm talking about boiling points. In the case of the boiling point, also we'll see. Mainly, it is determined by the hydrogen bonding. Hydrogen bonding.
Hmm.
So in when R group is hydrophobic and OH group is hydrophilic, so this is the main thing when we compare them. Second property which we discussed, student, is the solubility in water. Again, we will say that water solubility depends on if water is a
Uh,
polar protic solvent. Water is a polar, student, protic solvent.
hmm.
So those which can form hydrogen bonding with water will dissolve. So lower alcohols like CH3OH, C2H5OH. These will be dissolving because the group will form hydrogen bond with water. But as the R group increases, or AR group also, what will happen? These groups are hydrophobic, so the solubility will decrease fast.
Hmm.
Solubility decreases. Students, when R chain increases, or you have groups like AR, aryl or phenyl groups, so we can say that lower alcohols will be soluble in water, and as you will increase the number of carbons in the R chain, or if you will add aryl group, student solubility will fall immediately.
Hmm.
So I hope you have noted down this, then I will proceed further.
I'm copying, sir.
Okay, these are the physical properties, students. Physical properties.
Done, sir. Copy.
Okay. Now let us see the properties of chemical properties of alcohols. And alcohols are looking like these, students. There is a lone pair of electron on the oxygen. There is a RO bond. You have RO bond and you have OH bond.
Hmm.
So there are two possibilities in the reactions. Either this bond breaks or this bond breaks. Cleavage of RO
Yes, sir.
bond. There can be cleavage of carbon oxygen bond, student, or there can be cleavage of OH bond. Two things.
Hmm.
Cleavage. So when I will be discuss the cleavage, students, there are two possibilities which are there. This bond breaks or this bond breaks.
Hmm.
Let us see how. The interesting thing is about alcohols is that, student, alcohols are versatile in the sense that they can behave as electrophiles as well as nucleophiles. So alcohols can act as nucleophiles or electrophiles. Important.
Yes, sir.
So the question was there. Question is there that how will you prove? How will you show that alcohols can act as nucleophiles and
Hmm.
alcohols can act as electrophiles? How will you show it, student? How you will prove it? That is the question. Question. When alcohols will act as a nucleophile under what conditions? You see, when alcohols, I am saying first, let us see how the alcohols will act as nucleophiles.
Hmm.
As nucleophiles, this is my alcohol, student. There is a lone pair of electron on the oxygen. So if the oxygen will give its
Hmm.
lone pair of electron, then of course what will happen? It will act as a nucleophile. But to this is a weak nucleophile, is a weak nucleophile, student. It's not a strong nucleophile. So it will need some strong electrophilic, I mean, reagent where it can attack some electrophilic species. That means some positive charge should be there. For example, what is this carbocation?
Yes,
Your
sir.
organic chemistry student, carbon is carrying a positive charge. Now this is in need of electrons. This is hungry for the electrons. Therefore, now this can attack this carbon. Because this carbon is hungry for electron. This is a positively centered carbon. This is electrophilic carbon, student, and now it can
Hmm.
act as a nucleophile. But if this
Yes,
is
sir.
not there, then it is a weak nucleophile. Then that attacking is difficult. What will happen if it such a this is in need of electron? Carbon is searching for electron. It gets the electron from this. From where? It is getting electron from this oxygen, student. Oxygen is giving the electron to this carbon, the in the result will be this will become positive. But
Yes, sir.
once this becomes positive, student, oxygen is a electronegative element and oxygen is not happy with a positive charge, so it will try to get electrons to it needs electrons to neutralize this positive charge. And what it will do, it will take these electrons from here, and once it does that, what will happen? H plus will leave. H plus will leave,
Uh,
and what will happen, student? What you are getting is ROCC You are getting this compound now.
Yes, sir.
So what has happened in this when alcohol act as a nucleophile? When alcohols act as a nucleophile, which bond is breaking, student? Carbon oxygen or oxygen hydrogen? Which bond is breaking, students?
Sir, OH bond. Anyway, carbon oxygen.
Where is carbon oxygen bond breaking?
You said OH bond, yes, OH bond.
This bond is out. This is breaking.
Hmm.
And if the OH bond is breaking, student, is a cleavage of it is a cleavage of OH bond, breaking of OH bond. So OH bond cleaves. The result is H plus out. What is out? H plus. And that
Um,
means anything which gives H plus is known as what? Acid. So they are behaving as weak acids. In this reaction, alcohol is behaving as a weak acid. And what is happening? OR group is getting attached to the carbon, students, and there is a cleavage of OH bond. There is a cleavage of OH bond. That's what I'm saying.
hmm.
This bond is cleaved, student. Which one? This one. So this means alcohols can act as acid. This means alcohols can act as acid, and there will be question on that. Acidity of alcohol is an important question. We will be discussing the acidity of the alcohol. So alcohol can act as a nucleophile, but they are weak nucleophiles. So if they will have a strong electrophilic carbon or strong electrophilic reagent, then they will attack it. Strong electrophilic substrate molecule is there, they will go and
Hmm.
as you have seen, then OH bond is broken, H plus is released. That's why we say alcohols can act as acids.
Huh.
How acidic, that we will see. We will be spending a lot of time on the acidity of alcohols because one question is coming. Second important thing, you are saying alcohols can act as electrophiles. How alcohols can act as electrophiles, students?
Hmm.
I don't see anything like electrophile in this alcohol, but when if alcohols are protonated, student, in the presence of acid. How will they get protonation? H plus present. In the presence of H plus. If I add H plus, student, what will happen to the alcohol? If I add H plus, student, what is happening? This is my alcohol. RCH2OH. Okay? This is my alcohol. I
Hmm.
add to this H plus. You have seen large number of reactions are catalyzed by acids. As you will study,
Hmm.
acid catalyzed reactions. What is the function of acid, student? What acid will do? Now these electrons are available. They will take this proton. They will accept this H plus.
Huh.
What will happen then? RCH2 oxygen H comes here, and then this oxygen gets a positive charge. Is that what is this called? This is alcohol.
Uh,
What will you call this? A protonated alcohol.
okay, sir.
Proton has been added to the oxygen, as you can see.
Hmm. Yes, sir.
Now the result of this is positive. It will attract the electron towards itself. It will attract the electron towards itself, student. And this carbon will become positive.
Huh.
Electrons are going this way. This carbon has now become electrophilic, student. This carbon has become electrophilic. Which carbon? This one. Can see that
Hmm. Yes, sir.
this carbon has now become electrophilic due to protonation of the alcohol. So what is the result of this? If you have a nucleophile, student, then what it will do? You are having protonated alcohol. This is becoming positive. This will attack this
Hmm.
carbon and water. This is in need of oxygen. The oxygen is positive, in need of the electrons. It will take from here. Water is a good living group, will leave as H2 and RCH2Br plus H2O.
Yes, sir.
So now tell me which bond has been broken, students? Which bond has been broken? In this case, this is an example of nucleophilic substitution reaction. You have seen that Instead of OH group, you have Br now. This was OH, this bond is not there, this is broken. Carbon oxygen bond cleavage takes place. Student, carbon oxygen bond cleavage has taken place and is example of electrophilic reactions of the protonated alcohol. Protonated alcohol. Therefore, the question has been answered, which we wrote here. The question was given in one of the paper. Show that alcohols can act as nucleophiles and electrophiles. So we have shown it.
Mm.
Alcohols will act as a nucleophile when there is a carbon positive charge, and they will act as electrophiles when the protonation of the alcohol will take place.
Yes, sir.
Can I proceed further, students? You have noted, or you haven't to note everything? Note it down.
Yes, done.
Now we can say that when I discuss the chemical properties of alcohol, student, when I discuss the properties or reactions, there are two types of reactions, student. One reaction which will involve the one reaction which are involving the cleavage of OH bond, and second reaction which involve the cleavage of carbon oxygen bond. Okay? There are
Yes,
two
sir.
types of reactions. So first we will study the reactions of the alcohols in which there is a cleavage of OH bond.
Um,
That means we are talking of the acidity of alcohols. Okay? H plus is going to be out. What it means? We have studied acid-base theory branch. Anything, any substance which produces H plus ion is called acid. Therefore, if a question is given to you, now my lectures keep on answering questions which have been asked in papers. Question comes now to us. Give two reactions in which alcohols act as acids.
yes, sir.
Okay, question noted. And I'm giving the reactions in which OH bond is breaking. OH bond is breaking.
Yes, sir.
First reaction, we already know that alcohols react with acid, with metals. Alcohol, students, phenols, both of them react with active metals. Like, what are metals, student? Metals are those which can give electrons. Metals are those which can give electrons. So
Mm.
metal like sodium, potassium, aluminum, these are the metals, students. What will happen if they react with these metals? What will happen? What will happen? Supposing I have ROH. I put sodium in this. What will sodium do, student? Sodium can give electron, and what will be the result? Then you will get RONA. This is positive, this is negative, student. And what will happen? This H plus is out. What will happen to H plus, student? This will produce hydrogen gas. If I
Mm.
double it, so I can write it like this: 2 RONA, so 2 sodium. So you can see that when sodium is added to alcohol, what will be the result? Hydrogen gas will be liberated.
Yes, sir.
And it is important, when some gas is liberated, student, we can test it. How you can test hydrogen gas? You have studied in earlier classes.
Yes, sir. Sir, the pop sound experiment.
It burns with a pop sound. Burns with, is
Pop sound.
flammable. So we have seen in earlier classes that hydrogen gas can be tested. Sometimes it become a test for alcohol, student. If I say it is alcohol, okay, you say put a piece of sodium, you will see bubbles of hydrogen gas, student, which can be tested,
Mm.
So, for example, For example, student, if I take phenol, this also has a OH which can be broken. Cleavage of what I'm talking, cleavage of OH bond. I'm talking of acidity. And if I add
Hmm.
sodium in this, what you are going to get, student? ONA plus. This is called sodium phenoxide. Again, you will get hydrogen gas, student. Tell me. So balance
Yeah,
it.
yes, sir.
You will get hydrogen gas.
Yes, sir.
React sodium with metal, balance the reaction. What is this? Balance. So in these reactions, students, I have shown you. What have I shown you, student? The breaking of the OH bond. What I have shown? Breaking of the OH bond. Cleavage of the OH bond. And metal, you can take sodium, or here we have shown potassium, aluminium. If I react, students, supposing you are given CH3, CH3, student, CH3, OH plus aluminium, complete the reaction in the exam. I have given you, you are given 1 minute to complete this reaction. Student, what will be the products? What will be the products in this case, student? Write down. Here you know aluminium belongs to which group?
Yes, sir.
Group 13. This is group 1. Sodium is in group 1, student. And it forms Na plus. And
Hmm.
aluminum is in group 13. What it forms? Al3 plus.
Yes, sir.
So if you are giving 1 O minus, then you will need 3 O minus.
Hmm.
How you balance the reaction? Then what is the product, student? What will be the product? You have CH3, CH3, student, CH3, O minus, student, and there should be then 3 times of this Al.
Ah.
And because valency of aluminum is 3 plus, students, and then there will be hydrogen gas liberated, H2. So we have to balance it, student, balance it. Then it will come to be 6 and 2, 6 and 2 Al. Then it will become 2, and you are getting how many hydrogens are left? 6H means 3H2.
Hmm.
This is the reaction. This is the reaction, students. So all these reactions are becoming important, students. Sodium is an active metal. Sodium is an active metal. It has been able to remove hydrogen gas from phenol as well as alcohol.
Ah.
So the above reaction proves one thing. This is a base, this is an acid. That means this is a base, this is an acid. Therefore, we can say that the alcohols and phenol are acidic in nature. ठीक है? Alcohols
Hmm.
and phenols are bronzed acids. We can say, what we say? Alcohols, phenols act as, you have heard about bronzed acid base theory, bronzed acids.
Hmm.
They can give H plus, student, H plus. So base can take the H plus from them. Or we have,
Ah.
in acid base theory, we have heard about conjugate, concept of conjugate acid and base, conjugate acid and base, students.
Hmm.
Acid gives proton, base takes a proton, and the result is the formation of conjugates of them. Conjugates of them. For example, if I say this is my ROH, if this bond breaks, student, what happens then? You say RO minus and H plus. If this is an acid, what we call this as conjugate base. So we know acid gives conjugate base. Acid gives, this is what we talked of, Bronsted theory of acids and bases. In that we told you. But one interesting thing is there between phenol is more acidic than alcohol. Phenol
Hmm.
is more acidic than alcohol. Then what will be the result of that? You have noted down these things, then I will proceed further.
I'm copying, sir.
Okay. There are going to be questions on acidity of phenol. Is a very important topic. Acidity of phenol. There will always be one question on acidity of the phenol, student.
Yes, sir.
Okay. Now the key question is that we are talking of acidity of phenols, acidity of alcohols
Hmm.
and phenols. In fact, phenols are more acidic than alcohols. More acidic. We will show how, why, and how very soon. Phenols are more
Hmm.
acidic than alcohols, I am saying. And because of this, phenols also phenols react with NaOH.
Hmm.
With NaOH also phenols react, but alcohols do not react. Alcohols are not strong acids, ठीक है?
Yes, sir.
with aqueous NaOH. So this becomes a difference between the two. For example, if I have OH and react with aqueous NaOH,
Hmm.
what is the result? You are getting ONA and then OH minus and H plus will give what? Water.
Yes, sir.
So this is a reaction which distinguishes alcohol and phenol, students. So sodium phenoxide is formed with aqueous sodium hydroxide, but normal alcohols are not forming this, which shows phenol is more acidic than alcohol. Which shows phenol is more
Hmm.
acidic than alcohols. ठीक है? Further important points about the acidic character of alcohol. And what you said, acidic character of alcohol is due to polar nature of OH bond. Oxygen is highly electronegative. It can attract the electron and then proton can be released. Therefore,
Hmm.
what will happen? If we attach electron releasing group or electron withdrawing group, they will change the electron density on the oxygen. Hence, the acidity character will change. Why? Because what we said to you, this is our base. Base has a lone pair of electrons, student. It is reacting with alcohol.
Hmm.
And what we told you about Lewis acid base theory. Lewis acid base theory. This base will take the proton
Hmm.
and it will become BH. And what will it will become? OR, and this takes the electron OR minus. This is acid, then this is the conjugate base.
Yes, sir.
According to Bronsted theory, this is the base, then this is the conjugate acid. We have already discussed the acid base conjugate theory.
Yes, sir.
Bronsted theory, student, Bronsted. Therefore, I can say that, student, if an acid gives a proton and forms a conjugate base, if conjugate base is stabilized, if conjugate base is stabilized or a weaker base, if it is weaker, then it won't react and go back. But if it is not stable, if
Hmm.
it is not stable, what will happen? It will react and go back. It will react and go back. Therefore, the acidic character depends on what factor? All the thing I am trying to say to you, student, is something like this, that you are forming RO minus and H plus. If this conjugate base, this is my acid, If this conjugate base is stable, or if this conjugate base is a weak base, then reaction will proceed forward. If it is a strong base, it will react with H plus and go back, and then it will
Yes,
become
sir.
weaker acid. Then it will become weaker acid. Therefore, the groups which are attached to R group will decide the acidity of the alcohol. Because I can attach, you have noted down, then I will proceed further.
Yes, sir. Copy.
Okay. Important questions are coming now.
Yes, sir.
Okay. What I am trying to tell you that if you have something like RCH2OH and you have R R dash CHOH, then you have R1, supposing R2 R3 COH.
Yes,
What
sir.
is this type of alcohol? Primary, secondary, or tertiary?
So this is the tertiary.
This is tertiary.
No, sir. This is primary. This is secondary, and the third is tertiary. This is primary, secondary, and third is tertiary.
And this is my tertiary.
Tertiary.
So if we want to compare their acidity, student, what will be the order of acidity? What will be the order of the acidity, students? Arrange them according to order of the acidity: 1 degree, 2 degree, and 3 degree alcohols.
Yes, sir.
Which will be most acidic, students?
Um, 2 minutes, sir.
Think and answer the question. Don't answer the question
I
without
think primary will be the most acidic, followed by secondary, and then tertiary.
these are electron releasing group. What effect is that known as, students? Plus I
Yes,
effect
sir.
of R group. There are two plus I effects, and here there are three plus I effects. See, there are two R groups. What they will do? The conjugate base will be what? RCH2O minus plus H plus.
Yes, sir.
This is going to release electrons, will increase the electron density. But here, how many you have? You have CHO minus and H plus. You have two R groups.
Mm,
They will increase the electron density. This is my conjugate base, conjugate base. So this will become less stable. Thus, more the negative charge, less stable it is. And it will go back. It will react
Yes,
with
sir.
H plus. Here you have three R groups. How many? Three.
Three R groups.
R1, R2, R3, they are giving electrons and H plus. So they R group increasing the electron density on oxygen of conjugate base. Therefore, therefore, acidity decreases as you go from 1 degree, 2 degree, and 3 degree alcohols. Got it?
Yes, sir.
So the order is the order of react acidity order of acidity has been asked in the paper.
Mm.
RCH2OH more acidic than RCHOH is more acidic than R. ठीक है? 1 degree, 2 degree, and 3 degree. Okay, you have noted down, students. Noted down, students.
Yes, sir.
Okay. Another question answer students. Question: are alcohols weaker or stronger acids than water? H2O, than H2O.
Hmm.
Now, what is the answer? You have 1 minute. And there is an exception also here. I will tell you. Important question. Important question. Supposing I say CH3, CH2OH and water.
Hmm.
Question: which is more acidic? Question: which is more acidic, student?
Yes, sir.
What is the answer? In this case, water is more acidic than CH3,
Hmm.
CH2OH. Why? What is the reason? What happens if I water is ionized? What is the result of that? If water ionized, what it gives? H plus OH minus. Conjugate
Yes.
base acid. If CH3, CH2OH, what is the result? CH3, CH2O minus conjugate base. But this C2H5 group is what type? Electron releasing. Electron releasing. It increases electron density on the oxygen. On oxygen, students.
Yes, sir.
Therefore, this becomes stronger conjugate base. Therefore, it becomes weaker acid than water. It will go back. It will go back. It will react with this, go back, because this CH3, CH3 students, I put it this way, CH3, CH2O minus is stronger conjugate base
Hmm.
than OH minus.
Yes, sir.
Therefore, we are saying in general, students, alcohols are weaker acids than water. But there is an exception which I will tell you. Exception. Sometimes exception is asked in the paper. CH3OH is more acidic than water. Only one exception. One exception, students.
Hmm.
Rest, rest this statement will follow. This statement will follow. Note it down, student. We are discussing very, very important questions.
Hmm. Yes, sir. Yes.
You are done with, I will proceed further.
Hmm. Done, done.
Okay. Another question which was given, student, ethanol and phenol. Which is more acidic and why?
Hmm.
Important question, student. You have to answer it. You have 1 minute to answer the question. This question has been, whatever my lectures are, there are a lot of question answers in our
Hmm.
lectures. Yes or no? Tell me.
Yes, sir.
Why? Because question will be there in the paper. So you have to pay attention to all this so that you can easily learn what type of question answers are coming.
Hmm. Sir, out of these two, uh, phenol is more acidic.
Huh?
Sir, out of these two, phenol is more acidic.
Phenol is more acidic. Reason you have to give,
Yes, sir.
phenol is more acidic than alcohol. Why, students?
Sir, producing ions.
You have to show it. Very important question. Let us see, students, on what basis we will explain. You have CH3, CH2, OH, OH. When it gives students H plus ion, what will be formed is CH3, CH2O minus plus H
Hmm.
plus,
Yes, sir.
H plus. This is my acid. This is a conjugate base. This is a, what type of group is this?
Hmm.
Electron releasing R
Yes,
group.
sir.
So it is a weak, it is a, what will happen? This will become stronger. This negative charge will become stronger. Or I can say that this is a strong conjugate base. So if it is strong, it will react
Hmm.
back and go back. What effect is operating? CH3, CH2 plus I effect,
Yes, sir.
electron releasing effect of this. Plus I effect operating, student दिख रहा?
Mm-hmm.
इलेक्ट्रॉन रिलीज कर रहा है ये ग्रुप, प्लस आई. Now what happens in phenol, student? It forms O minus and H plus. This ion is
Hmm.
called phenoxide ion.
Yes, sir.
Phenoxide ion. Now this, there is a lone pair of electron and conjugated system. Benzene ring can withdraw these electrons through conjugation. The negative charge is dispersed now not only on oxygen, it can spread on the entire benzene ring. What it will do? Phenoxide ion, this is a conjugate base. This is my acid. This conjugate base, student, this conjugate base, which is phenoxide ion, student, this is a resonance stabilized. Resonance stabilized, student. What effect is operating? Plus R effect. How? Can you draw the resonance structure of this, student? Can you draw the resonance structure of this?
Hmm.
How will you draw the resonance structure of this, student? 2, 4, 6. This is negative.
Hmm.
Pi electron can shift, student. O double bond, students. Negative. And what will happen, student? This negative charge is shifting. Negative charge is shifting. There are now 2, 4 electrons left. And
Hmm.
this shifts to this point, student. What happens? Double bond. This negative charge has shifted here, this here. Then what will be the next stage, student?
Hmm.
Now this negative
Yes.
charge is stabilized by resonance. Therefore, what will happen? This is stable. It won't go back. Conjugate base
Hmm.
is more stable. Or this phenoxide ion is a weaker conjugate base because the negative charge is not on oxygen. It is dispersed on the different parts of the benzene, as you can say. So the negative charge of the phenoxide ion is not is delocalized. But I'm saying the negative
Hmm.
charge of phenoxide ion student is delocalized. It is not local on oxygen. Delocalized student. ठीक है? The negative charge of phenoxide ion is delocalized by resonance. What will be the result? What will be the result, student? What will happen? So this has become more stable, more stable. ठीक है? More stable.
Hmm.
Thus,
Hmm.
thus the phenol is more acidic than ethyl alcohol. Phenol is more acidic than ethyl alcohol, student. If you will see the pKa values, you will see for ethanol, the pKa value is around 15.9.
Yes,
And
sir.
if I see phenol, student, phenol, the pKa value is 10. Lower the pKa, stronger the acid. Lower the pKa, stronger the acid. So questions can be put in many ways, students. Be careful and alert. Be careful
Hmm.
and alert when we will discuss these question answer session, students. Any doubt up to now, students?
No, sir.
Okay, then we will continue more about this because a lot of questions will be discussed, students, in all these our lectures. And here we have given you the first important reactions in which what we are finding, they we are showing you the acidic behavior of alcohol, the cleavage of OH bond, and we will continue more about the chemical properties of alcohols and phenol in our next lectures.
Hmm.
I thank you and good night, students. We'll meet you in our next
Yes.
class.
Thank you, sir.
You have noted down everything, students?
Hmm. Yes, sir.
Want to note down everything. Anything left?
No, sir.
Noted or you are noting, students?
Noted, sir. Noted, noted, noted.
Noted.
Okay.
Okay, then good night.
Thank you, sir.